Hello friends, welcome back. In this video, we are going to see how to correct an error. In the previous video, we have seen error correction technique or error correction code, that is an Hamming code. In that we have already seen how to correct and detect the error. So same technique we are going to use here. As you can see, I have taken one example and this bit has been received at a receiver end. We have to check and correct code when even parity is used. Okay, so now we'll start to solve this. First of all, obviously, for correcting an error we have to detect an error. So as you can see, this structure, already we have seen this structure in the Hamming code. That structure is D1, P2, D3, P4, D5, D6 and D7. D means it is a data bit, P means it is a parity bit. Now I have just put on the values of this example 11011011. Okay, starting from the right hand side. Okay, now as we have seen in the previous video, we have seen the grouping of the parity bits. Like for example, P1 has a group of 1357. 1357. Similarly, P2 has a group of 2367 and P3 has a group of 4567. These are the parity bit grouping that we have already seen. How we have calculated it, that we have also seen in the previous video. So for understanding it better, I would like to suggest, don't forget to watch the Hamming code video or the error correcting code video. Now how we are going to identify the error in this string? See, similarly like this parity bit grouping, we are going to group the error bits E1, E2 and E3. E1 group would be 1357, 1357, similar like the parity bit. Similarly, E2 would be the group of P2, 2367 and E3 group would be P3 group, means parity bit third, sorry, it would be P4 because we write it as an P4. Okay, and it would be P4 group 4 5 6 7. So similarly we are going to calculate the values of E1, E2 and E4. Okay, now see 1357, at one position it is 1, 3 it is 0, at 5 it is 0, at 7 it is 1. Okay, now as we are using even parity, if we are using even parity, if the number of ones are even, then we are going to add 0 as an parity bit. Similarly, we are going to add 0 for the error bit. If number of ones, as you can see 1 and 2, there are two number of ones, so obviously 2 is an even number, so we are going to add 0. Now here we are going to again put on the values 2 3 6 7, 2 3 1 0 6 7 1 1. Count the number of ones 1 2 3. How many number of ones are there? There are 3 ones, means it is an odd number. So we are going to add 1 as an error bit or a parity bit to make it even, because we are using even parity here. So if the number of ones are odd, then add 1. If the number of ones are even, add 0. Okay, now we will calculate E3 4 5 6 7, 4 5 6 7 1 0 1 1. Okay, 1 again calculate, again find out number of ones 1 2 and 3. Again it is odd, so we are going to add 1 to make it even. So we are using even parity. Now what we have to do, we are going to write E1 E2 E3 in a sequence. What is E1? E1 is 0, E2 is 1 and E3 is again 1. So now what we have to do, we have to convert this binary value into a decimal value. So simply we can use technique 8421. So it is 6. Decimal value of this is 6. 2 plus 4 is 6. Okay, so it is 6. So as you can see, this 6 is the place of bit where error is occurred. Okay, it is a place of bit where error is occurred. If it is 0, means there is no error, but if it is some another value, means the error is at that particular place. So we are getting value 6, means error is at 6th position. So we can say the code that we have received is having an error. If E1, E2, E3 is 0, means there is no error. The code is error free. So if we are having error at 6th position, see, now till here we have just detected an error. There is an error at 6th position. So if we know there is an error at 6th position, now we want to correct the error at 6th position, means what? Obviously the bit is 1. If it is an error, what would be the right code for it? Right, what would be the right bit for it? It must be 0. It must have a 0. Means if we are at 6th position, there was an error. Obviously if 1 is an error, the bit that we should receive was 0. So we can easily correct the error by knowing the position of the error. Because we are using binary value, if you know the position of an error, if we have an error, if it is 0, we can say the correct code would be 1. If we are having 1, we can say correct code would be 0. So simply we can identify the error and correct the error with the simple technique that we have seen in this video. So I hope you understand. If you understand, don't forget to like and subscribe my channel and share my video with your friends and family. Thank you.